Sound, it's literally everywhere, right? From the music you're listening to the buzz of your phone. But have you ever stopped to think about what it actually is? We're about to dive into the secret science behind this invisible force. And trust me, it's way cooler than you think.
So let's kick things off with a classic mystery you've probably wondered about a million times. During a storm, why do you always see that bright flash of lightning, and then, a few seconds later, you finally hear the massive boom of thunder? The answer has everything to do with what we're talking about today. To crack that mystery, we've got to start at square one. What even is sound? Well, at its very core, it all boils down to one simple, powerful idea: vibration. Okay, so think of sound as energy that's on the move. When anything vibrates, a guitar string, your vocal cords, anything, it pushes the air particles around it. This creates these invisible waves that spread out in all directions. It's just like when you toss a stone into a calm pond and see the ripples expand. That's exactly what sound is doing in the air all around you, all the time.
But here's the catch. Those waves can't just travel through nothing. They need stuff to move through, what scientists call a medium. That can be air, water, or even a solid object like a wooden door. And this is why space movies that show silent explosions are actually getting the science right. In the total vacuum of space, there are no particles for the sound waves to push. So no medium, no sound. Simple as that.
So every single sound you can possibly hear has two main features. First is its pitch. That's how high or low it sounds. This is determined by its frequency, which is just a fancy way of saying how fast the sound wave is vibrating. The other is volume, how loud or soft it is. That's all about its amplitude, which is basically how tall the wave is. A taller wave means a louder sound. We actually measure frequency using a unit called hertz, or Hz for short. 1 hertz is equal to just 1 vibration per second. So a super high-pitched whistle is vibrating like crazy, maybe thousands of times per second, giving it a high hertz value. But that deep boom from a bass drum, that's a really low frequency, meaning way fewer vibrations per second.
And for loudness, we use a unit called decibels, which you'll see written as dB. Now the decibel scale is a little weird. It's what we call logarithmic. That means a sound at 20 decibels isn't just a little bit louder than a sound at 10 decibels. It's actually 10 times more intense. A quiet whisper is around 30 dB, and a normal conversation is about 60 dB. Doesn't sound like a big difference, but that conversation is actually 1,000 times more powerful than the whisper. Crazy, right?
So we have these invisible waves vibrating all around us. But how do they go from being just waves to becoming music, voices, or warnings inside our heads? Well, let's follow the incredible journey of sound as it travels right into your ear.
How does a simple push of air particles turn into something your brain can understand as your favorite song or the sound of your name being called? The process is an absolute masterpiece of biological engineering.
It all happens in 5 amazing steps. First, your outer ear, the part you can see, acts like a funnel, collecting sound waves and guiding them inward. The waves then travel down the ear canal and hit the eardrum, causing it to vibrate. Then 3 of the tiniest bones in your entire body, the hammer, anvil, and stirrup, act as amplifiers, making those vibrations stronger. That boosted signal then enters the cochlea, a spiral-shaped tube that converts the vibrations into electrical signals. And finally, those signals are zapped to your brain, which instantly interprets them as sound.
But you really need to know that this whole system is incredibly delicate. The tiny hair cells inside the cochlea are the key players, but they can be permanently destroyed by sounds that are too loud. Think a rock concert that's over 120 decibels. And here's the scary part. Once those cells are damaged, they're gone for good, they do not grow back. That's why protecting your hearing is such a big deal. Okay, so we know what sound is and how our ears work. Now, let's take a look at how sound behaves out in the real world when it interacts with different things. And here it is, the answer to our big lightning question. Light travels at an absolutely insane speed. It's pretty much instantaneous. Sound, on the other hand, is much, much slower. In air, it cruises along at about 767 miles per hour. But here's what's cool. It travels way faster through denser things like water or steel because the particles are packed tighter and can pass the vibration along more efficiently. So you see the lightning instantly, but you have to wait for the slower sound wave of thunder to actually reach you. Have you ever shouted into a canyon or a big empty gym and heard your voice shout right back at you? That's an echo. It happens when sound waves hit a hard, flat surface, like a wall, and bounce straight back to you, kind of like a tennis ball. But soft surfaces, like carpets and curtains, do the opposite. They absorb sound, which is why a furnished room always feels so much quieter. And we've gotten really smart about using this bouncing effect. We use sonar to send out sound pulses and listen for the echoes to map the entire ocean floor. Animals like dolphins and bats use a natural version of this, called echolocation, to see with sound. And architects even use echoes to carefully design concert halls so the sound reflects perfectly to every seat.
Okay, prepare to have your mind blown a little bit. The world is absolutely filled with sounds that you can't even hear. There's a whole hidden universe of frequencies out there that are totally silent to us.
Remember frequency, which we measure in hertz? Well, a healthy human ear can typically hear sounds from about 20 hertz on the low end all the way up to 20,000 hertz on the high end. Now that might seem like a huge range, but in the grand scheme of things, it's just a tiny little slice of all the sound waves that exist.
Anything above that 20,000 hertz mark is called ultrasound. It's way too high-pitched for our ears to even register, but it's perfect for bats using echolocation to hunt for tiny insects, and it's what doctors use to create medical images of the inside of the human body without any harmful radiation. And on the flip side, anything below 20 hertz is called infrasound. These are incredibly deep, powerful sound waves that can travel for hundreds of miles. We can't hear them, but we might sometimes feel them as a rumble. Elephants and whales use these low frequencies to communicate across vast oceans, and they're also produced by huge natural events like earthquakes and volcanoes.
So, with all this incredible knowledge about sound, what can we actually do with it? Well, let's look at just a few of the amazing ways we've learned to put the power of sound waves to work.
Okay, here's a classic question you've probably seen in cartoons. Is it actually possible for an opera singer to hit a really high note and shatter a wine glass with just their voice? The answer is absolutely yes, and it all comes down to a really cool principle in physics.
The secret is called resonance. Basically, every object in the world, from a tiny glass to a huge bridge, has a natural frequency it just loves to vibrate at. If you can produce a sound at that exact frequency, it's like giving that object a perfectly timed push on a swing over and over. The object absorbs the energy, starts shaking uncontrollably, and with enough power, it can literally vibrate itself to pieces. And when you put all these principles together, resonance, echoes, frequency, all of it, you can unlock some unbelievable technology. It's how we design beautiful musical instruments. It's how we create soundproof rooms. It's how engineers build massive bridges that won't collapse from the resonance of the wind. It's how we see inside the human body and map the entire ocean floor.
So from the quietest whisper to the loudest thunderclap, sound is this fundamental force that's constantly shaping our world in ways we can hear and in many, many more ways that we can't. Just by understanding these simple vibrations, we have completely changed the world with technology. And that just leaves one big question. What will we unlock next?